So with rational functions, we did a whole bunch of these guys. Remember that? I think there are 6 of them. 1, 2, 3, 4, 5, 6. All on graph paper, or you were putting them in your math notebook. But we graphed them without technology, right? And now we are being asked to solve an inequality that involves a rational function. So if we can get the graph down, we're going to have that situation where I could shade it in red and try to figure out what the x values that satisfy this inequality are. Okay, now maybe I'm getting ahead of myself. Let's see if we can follow the steps with this guy right here. Now it says factor the numerator and the denominator of r. Most of our problems have already been factored for us. I know some of them that aren't factored, that cause a whole nother set of challenges. But we're going to get better at factoring. We have a couple sections where we're going to have some tools that we're going to use to help us find the zeros, right? That's the important part, is find the zeros of the denominator and find the zeros of the numerator, right? Well, this is already factored, check mark. Then it says put r in lowest terms. Are there any common factors between the numerator and the denominator? No common factors. Okay, so it's already simplified, right? It's in lowest terms. Let me zoom in on this as we take eagle eyes to read this. Find and plot the intercepts of the graph. Use multiplicity to determine the behavior of the graph of r at each x-intercept. Okay, that's very similar to what we were doing with the polynomial, right? So how do we find the x-intercepts? Well, it's only the numerator that can make a fraction equal to 0. So all we have to do is look in the numerator and set any factor in the numerator equal to 0. So x plus 1 equal to 0 will tell me the x-intercept. So I've got -1 from x-intercept. It had a multiplicity equal to 1 because it's like x plus 1 to the first power. There's only one x plus 1 factor up there. That means it crosses at x equals -1. So on my graph, I could just go over here and put down a little dot at where I think -1 is. I mean, that would demonstrate I understand my x-intercept. Now, if I do this little number right here, I don't know if it's coming from down here and going up or if it's coming from up here and going down. So that might be a little premature to put down a little slash through the thing. Okay, I wouldn't do that yet. The next thing it says, let's make sure I don't miss something here. They'll use the multiplicity to determine the behavior of r at each x-intercept. Okay. Oh, shoot, man. Why did I put it crosses right there? And I put over there that shoot, that is the right word. It's early in the morning, sorry. Yeah, it definitely crosses because it's an odd multiplicity, right? Gosh, man. Find the vertical asymptotes. Oh, this one's not too bad, right? You look in the denominator. Where does the denominator equal 0? That's the question we're trying to answer. And what are the factors in the denominator? Well, an x and an x plus 4. So where is x equal to 0? My question has the answer in it, right? That when x equals 0, then x is equal to 0. And the other factor was x plus 4. So I go x plus 4 equals 0. That's when x equals -4. So we come over here to our graph and we put, let me make sure I don't forget this, is -4 and 0, right? I'm going to put a vertical line at where I think -4 is. There's x equals -4, and then I'm going to put a vertical line where x equals 0 is. These are my asymptotes. Okay, let's see, what else do I have to do on that step? Zoom out here. Find the vertical asymptotes, graph each vertical asymptote using a dashed line, determine the behavior of the graph of r on either side of the vertical asymptote. Okay, now this is kind of cool, that each power on these factors up here in the denominator, let's see here, is a 1. Okay, let me put this right here, 1 and a 1. That means it's going to be doing opposite things on either side. Like it's either going to be going down on the left and up on the right, or vice versa. It's going to be going up on the left and down on the right. Once I figure that information out, man, things are going to fall into place. I also want to make sure that I have maybe my y-intercept on here. Did I skip over that? Where the heck do they tell us to do the y-intercept? That might not be for a little, well, I don't know where it is, but I'm going to find the y-intercept right now. If I plug in, let me put this down, y-intercept. If I plug in 0 for x, I would get 0 plus 1 in the numerator. In the denominator, I get, oh, wait, we already figured out that when I plug, oh, no, I didn't figure that out, did I? Oh, it's undefined. That's why you see my hesitation here. I'm like, well, if I stick 0 in for the denominator, I get a 0 in the denominator, which is equal to, 1 over 0, which, oh yeah, it's undefined. Duh. I had a vertical asymptote there. It's not going to hit the y-axis, dummy. Sorry about that. That was a waste of our time. Okay, so let's see. Find the vertical asymptote, graph each vertical. Oh, we're determining the behavior, right? So I'm trying to figure out an easy way to determine the behavior here. I'm not feeling like there is a super easy way. So I'm just going to take the point or a value of negative 4.1 because that's to the left of the negative 4. And if I can figure out which way the arrow is going, I think I'm going to be home free, okay? So when I put negative 4.1 in for x in the numerator, I get negative 4.1 plus 1. And it's all over negative 4.1 times negative 4.1 plus 4, which comes out to be, let's see, negative 3.1 in the numerator, and down here I got negative 4.1 times negative 0.1. See, this is the thing that's going to happen every time when you stick a number close to the asymptote. One of the factors is going to be really small. And when you take a really small number times something else, a really, really small number, it's going to be small, and it's going to be small in the denominator. So I'm going to put, look, it's a negative times a negative. I'm just going to put a positive small down here, okay? I don't really care that it's negative 0.41 because I'm really not going to do any more arithmetic. I'm just trying to figure out, is this going to be a positive number or a negative number? And you see that I've got a negative in the numerator. So if I take a positive small into a negative, I get a large negative. Large negative. So what does that mean about my behavior near the vertical asymptote? I don't want to put that in red. It's going to be going down over here. That means that it's got to be going up on the other side of the asymptote, right? Now, look, it's got to get down to this x-intercept. And you remember how we said it crosses at that x-intercept? So let's put that little tick now going the right way. It's crossing like that because we know this arrow's up. How'd I know this arrow was up? Because I figured out that arrow's down. Now, if I mess something up over here, then all of this is going to be messed up. Like, if I had my arrow going up over here, then I'd have my arrow going down over there. It'd be all just backward, right? But I hope I got that right. So now I'm going to come down. I'm going to go through the x-intercept. Look, there's no other x-intercept here, so it's got to keep going down. Like if there was another x-intercept here, I'd have it come back up, cross through, and I'd have it go back up toward this asymptote over here. But since it crossed through, it's got to keep going down and get closer and closer to the vertical asymptote. That means on the other side, it's going up on this side, right? And now I've got to figure out my end behavior. Notice I don't have any arrows going out here to the right. I don't have any arrows going to the left because I haven't figured out the end behavior yet. That's coming up next, all right? So it says find the horizontal or oblique asymptote. Now, let's see if I can get this on the screen here in the same space, okay? So you notice the degree in the numerator is 1, okay? So really, I'm going to drop the little plus 1 right here and just put down like I've got it behaving in the numerator like x. In the denominator, we got like x times x. So it's x squared. This is the same kind of consideration we did when we were considering end behavior of a polynomial. We didn't do all of the stuff. We didn't worry about every single factor. We're just worried about the ones that are important. The leading terms in the numerator and the denominator. In this case, in the polynomial, we only had a numerator. So because the degree in the numerator is less than the degree in the denominator, this thing is going to have a y equals 0 horizontal asymptote. Because the denominator is going to grows faster than the numerator. Okay? What happens when you have a fraction that has a bigger denominator than numerator. Let's say we had big here and small there. Like, let's say we had 1 in the numerator and we had 10 million in the denominator. Okay, what would happen? Well, this would be like 0.000000. I don't know if I'm going to have the right number of zeros there, but it'd be a lot of zeros and then a 1, right? A super small number, right? We get a small number. That's approaching. Here's the way you say it in calculus. You put a little arrow. Approaches 0. All right. So here's what I'm going to do with my curve over here. Because I have a y equals 0 horizontal asymptote, I'm going to make the left side right over here. I'm going to get from this arrow and I'm going to get it closer to the x-axis. That's my horizontal asymptote. Just make it bend that way. Am I going to let it hit there? No way, because I only have one x-intercept. All right, and the x-intercept's right over here. People get all worried about it crossing over the horizontal asymptote. Is this a very big number or just kind of a normal number? -1's kind of normal, it's not big. So it has nothing to do with end behavior right here. This has to do with end behavior right here. That arrow saying, hey, you know what, as we go out this way, we're approaching that horizontal asymptote at y equals 0, right? I got to do the other side of my graph. What is it going to do? Let me zoom out. Well, I got my arrow at the top up there, see it? Here's my arrow at the top. It's going to come down, and it's going to get closer and closer to the x-axis, okay, because that's my horizontal asymptote. I got to make that extend over here, my red dashed line, okay? That's what a rational function looks like. It has vertical asymptotes, quite often it has horizontal asymptotes, or a horizontal asymptote. And here's what our rational function looks like for this homework problem, all right? So what was the homework problem asking? Where is the function bigger than 0? Okay, so now what I do is I go, okay, my function is bigger than 0. Let's try this way. Turn the highlighter on. All of this stuff right here is bigger than 0. All right, and then all of this stuff over here is bigger than 0, right? Remember how it goes out there? I'm not going to zoom at all. So all of this is negative. And so how am I going to answer this question? Well, I want all the x values that are between here and here, and I want all the x values that are like all of this stuff over here, right? So how do I answer that question? Well, kind of tough to get this all on the same screen at the same time. These numbers are going from -4 over to -1. So here's the way I would answer this question. I would say from, and I don't want an equal to, so I'm going to say from -4, we never could have it equal -4 because that's a vertical asymptote. And then we're going to go over to -1, and we're not going to include -1 because that's where it's equal to 0. We wanted everything greater than 0. And I'm going to do union all the stuff that's greater than 0 out to infinity. And I like interval notation. I don't know how you feel about it, but this would be my answer because this part of my answer right here is, I hope this lets me move it. This will be kind of disappointing if it doesn't. Moves the whole thing there. Is this part of my graph right there, okay? And let me see if I can do a little trickery here. So here we go. I'm going to see if it lets me grab this guy right here and move it right over there. This part of my answer is that blue stuff right there, and this part of my answer is that blue stuff over there, right? Okay, man, I hope I'm making this clear. If I'm not, you're calling me over for a little extra help on a homework problem, all right? This is what we're going to have on our test where you have to graph without technology. Thanks for watching, everybody.